Hello and welcome to our quick presentation on the Empower. The sound in the background is we're going to start by showing how an analysis data is gathered. So first thing we want to do is make sure that we have a motor nameplate. And we're going to call this test lab. Okay, so we have this here. We're going to call this 0.6 kilowatt, and we have all our other information here. Rotor bars, let's say there are 28 and there are 36 stator slots. We'll enter in the bearing information later. Let's go to coupling and driven and settings. So settings, this was already set before. We know that this says 100 millivolt per amp. So let's go ahead and save this equipment. All of these settings are default. We come in here and we will save this as small motor 2. Okay, so that's it. Now we've saved the data and we would be able to collect information. So just because I have motor data already for this particular machine, let's go ahead and gather that. So let's go to MotorDoc AI. There's our test motor. We'll open it. And when I come over here, you'll see that I have my data already entered. And in settings, I have this set up as well. So I have all my data now. So when I gather this information, we'll pause while it's being gathered because it will take just a little bit. When we click on analysis, you can see everything running in the background. Yes, there is some choppiness in here. That's because this is taking snapshots. Now the motor's running at 50 hertz. If it was running at 60 hertz, I wouldn't see that. When I go ahead and I collect data, I click on this and this will freeze and this will start a countdown for 120 seconds. That's the amount of data we're going to gather to get 0.009 hertz resolution across 22 kilohertz. So let's go ahead, we'll start this and then I'll put this on hold. Oh, there we go. It's asking for this. Now this is the default. It's going to tell me date and time. It is going to save it as a WAV file. I can call this whatever I want. Let's go ahead and save it as the date and time. And if I come back here, you will notice that this is running. So there's the countdown. So we will pause and I will restart when we have about 5 to 10 seconds left. Okay, so it has finished. This is still sitting back there. It pops up and it says, basically tells me that it saved the data. So I click OK. That's going to trigger, and you can see in the background, we're going to keep these screens available. It'll stay in the background. It's going to go ahead and process the data that we just collected. And you'll notice as soon as it's done, the window in the background will disappear, the data collection window, and all of the stuff up front will start to populate. And we don't need that running now. So we're going to go ahead and used to be more than 2 minutes to analyze data, but let's show you what we have first. So in this screen, we have our current. This will be peak to peak. I can zoom in on this by coming in here, taking a slice, and so on. But no fear, if I want to take a closer look at whatever, I'm going to be able to do that in a little bit. I can move this back and forth using this. I can save just a screenshot of this using save. I can step back through what I just did or go straight back to the original wave shape. I can do that with everything. Okay. I can also do it when I come in here to estimated watts. There's the same navigation, and here's the peaks in kilowatts here. Okay, so this is actually watts. So this will be in watts here. So in any case, and it'll analyze it in watts. You can see that when we end up doing this analysis, which comes from this data. The motor nameplate's still there. We will go through this as well. We'll do that separately. So that's all set. So once we have this up, now we can calculate the motor speed and have this analyzed. Now, if I don't have this data, it's just now it's going to just skip it. In version 1, it would troubleshoot anyways, but now it will actually just ignore anytime if you leave out that information. It just won't look. So when we're here, we click Auto Analyze, and you can see in the background it's just gone straight through. It used to take 90 seconds for it to hunt down the speed. That is no longer the case. It's instantaneous, less than 1 second. And that is a new algorithm that we had developed. And it's going to look at pole pass frequency and speed at the same time. It's going to find those, and that's it. So all the time we have now is it's doing all the analysis and identifying where markers are going to go in all these screens. We're leaving that for version 1.1. And as soon as it's done, it's going to refresh all the images. That's the pause. We made the decision not to do one step at a time, just because it might help people to think that it's done at any time. It's better to just show it outright. So motor speed and all the other components will pop up. Now, if I don't agree with the motor speed, even before I do the analysis, I can put in what I think the motor speed is from whatever information I have. But this is going to be very, very accurate. And we can see that by coming straight in here. There's the speed right there. So it's picked out the speed off of 50 hertz, so 24.93 times that would end up with this. So that is very exact. This was, it was 80-some% accurate before, or greater than 80-some% accurate. Now it is better than 95% accurate in picking out speed. That means I can be very, very happy with this information here. You can see it's calling out an ODE bearing, and you can see that all these markers, black markers are the bearings, and then all of the other stuff out here. Winding stress, it's on a drive that's not set up properly, so it's showing the winding stress signatures all throughout. So it's selected that. That means the drive's not set up properly. So I can now take a look again at watts, and you can see that it's picked these all out. And I can even zoom in again. Now it's going to show the box both vertically and horizontally, and you can see that we've identified everything here. And if I go in, I go even tighter, I can actually see the peaks if there are any. Okay, so once I have done that, or if I want to take a look at that, I should say, I can come back here, and you'll notice this looks an awful lot like vibration. When I go to kilowatts, all the peaks are in orders and everything else. The ground noise goes away. Additional data you can see here. It's now calculated everything, and it said the ODE bearing. So if I look down here, it's going to be the ball. You see it's half a watt losses there. And I can see all my other losses based upon whatever the frequencies are here. And then if I want, and if I've added in information like the number of operating hours and the energy cost, and I use the default settings here, when I analyze, it's going to calculate all of the opportunities, the losses, and everything else, including how much it's consuming now running at that load 24/7. Okay, and it's, as you can see, it's showing as overloaded, even though the motor is not connected to anything, and that has to do with the drive settings. So if I wanted to say that this machine was actually a pump, see it says pump or fan. I go over here, and let's say it has 5 blades. I could then put in my bearings for the pump as well. Have to have this checked, analyze driven. It's going to pop up another screen. There we go. And this, as you can see, is a much larger screen, but I have all the other capabilities of going in and seeing what it thinks it sees. And if I go back to my main screen, it will add anything that it thinks it sees. Now you'll notice that there's some drive stuff here. So this is the firing frequency of the drive, and this is the second harmonic of that. Well, supraharmonics, or harmonics greater than 2 kilohertz, are a direct result of inverters and so on. And this is a new area that we're delving into. There's new standards that look at 2 kilohertz to 150 kilohertz because of the harm that it does and its ability to blow away shaft brushes and things like that and give you fluting issues even when you think you've corrected for it. So we have added in another capability. So if I select harmonic here and I click Analyze Driven, it's going to run an analysis. Now first it's going to show me the spectra out to 22 kilohertz. I can use this to do whatever troubleshooting I want. And then if I click on harmonic analysis, that the peak-to-peak current waveform is going to show up. And that's going to allow me to do all that stuff I was doing before, but on a larger scale. So it takes 120 seconds worth of data, but because I have to wait for things to settle, I chop off the first 10 seconds. So I can see here, you can see that waveform, and you can dig all the way down because we're at 0.009 hertz and see what that waveform looks like. And then I can click on the harmonic. Now, when this now runs, this is one of the new features, it will pull up my harmonic. It's going to give me my percentages, including super harmonics, even harmonics, and everything else. I can also go in, because this goes out to the 367th, and say I want to just take a look all the way down to 0. Here are my harmonics here. If I leave everything the way it is, and I come back here, I can type in and say out, whoops, and save this. It's going to want to save it into that same folder and say harmonic analysis. Save that. It's going to save a harmonic analysis, which will be all the images there the way I left them. And then if I come back here after I've done all this stuff and I save PDF, that's going to do the same thing. I can do that as well. Let's say it's the 29th. So let's put in the 29th. Okay, so I've saved it, and now I can actually open those as PDF files. And those will show the reports. That will be in the overall summary. So I have my speed, I have everything else. This is all calculated automatically for me, and so on.